Assalamu alaikum. Hope you are doing very well. I am SM Zain and welcome to my class. Today I am going to represent a topic which is called deadlock. Deadlock is a very important topic of operating systems. Before learning about deadlock, let's understand the resource allocation graph. In the board, we can see two types of resource allocation graph. Let's understand first one. Here we can see two types of shapes. One is rectangular and one is circular. Rectangular shape represents the resources of a computer system. Something like hard drive, CPU cycles, RAM, secondary memory or which is called primary memory. And the circular shape represents the process P1, P2, P3. Now there are two types of graphs. One is single instance and another is multiple instances. Here we can see it's a single instance graph. The resource has only one instance. And this graph is multi instance. Here we can see a resource have double instance, this have triple instance. There can be more resources which can have almost any number of instances. So now what is deadlock? Deadlock is a situation when a process is holding an instance of a resource and requesting for an instance of another resource. And the requested resource is held by another process and it is requesting another instance of another resource which is held by another process. Because of this, none of the process can execute and show a situation which is called deadlock. For the presence of deadlock in a system, there are four conditions which should be met, and they are: first one is mutual exclusion. First one is mutual exclusion. This means that none of the process can execute at a time only one. None of the process can execute at a time. Second one is hold and wait. Hold and wait. Here we can see this process is holding this resource and waiting for this resource. Before executing the process, it is not left out the instance of the resource. Third one is no preemption. No preemption says that if a process is holding a resource instance, before executing the process, this resource can't be free or preempt this process. This process can't be preempted before executing this process. And the last one is circular wait. In this graph, we can see that there is a circular wait. P1 is holding R1 and requesting R2. And R2 is holding P2 is holding R2 and requesting for R1, which is held by P2. We can see a circular wait. We can also see a circular wait in this graph. We can see a circular wait in this graph. Now, for two type of graph, we can say that we can detect the deadlock only by seeing graph if it is a single instance. If the graph is single instance and there is a circular wait or a circle or a loop, we can say that the system is in a risk of deadlock. But if there is multi-instance and also a circular wait, we can say that there can be maybe may be a deadlock, but we cannot ensure. Here we can ensure there must be a deadlock, but we cannot ensure that there is must have deadlock. For this situation, we use Banker's algorithm. Banker's algorithm. If we find a safe sequence in Banker's algorithm, we can see that there is no deadlock, and if there is not, we can ensure that there is a deadlock. That's all. Thank you.